Hello, my name is Eric Bidstrup. I work at the Security Engineering and Communications team here at Microsoft, helping product groups throughout Microsoft build more secure software by following the security development lifecycle. While there's a number of different development methodologies that are commonly used in commercial software development, spiral methodologies, waterfall methodologies, or even agile development, all of these at their core have very common things that they share between them. Typically, early on you gather requirements to identify what problems your software is going to be addressing, a design phase that is figuring out from an engineering point of view how you want to go about solving those problems, followed by an implementation phase where coding is typically done, a verification phase where the code is tested, releasing the software, and then ultimately supporting and servicing the software after it's in the customer's hand and after it's been released. In our experience, we found that there are different types of activities that are very helpful for product teams to follow in each one of these stages to help them build software more securely. Very early in the requirements phase of the project, it makes sense to identify what types of security metrics and quality you're going to achieve. Here at Microsoft, we use some of the information that is provided by the Microsoft Security Response Center, looking at how they grade criticality as security defects and making sure that product development groups understand those and indeed take actions to make sure that all such issues are corrected prior to the product being released. Moving on to the design phase of the project, there's a number of different practices and approaches that we encourage teams to follow as part of the design phase. There's a number of behaviors such as security design reviews that look at things from an architectural standpoint to make sure that design is secure from the ground level up. Various other things such as minimal cryptographic standards that we ask teams to follow, avoiding use of older algorithms such as MD4, MD5, and SHA-1 that have been shown to have cryptographic weakness. And then we also encourage teams to pay a great deal of attention to something referred to as attack surface analysis. This is essentially looking at all the possible points in the system that the software could possibly be called and ways in which an attacker may try to take advantage of and exploit this. This will be talked about a little bit more in some of the later presentations. One of the other very critical elements that we encourage teams to do during the design phase of the project is something called threat modeling. Threat modeling, simply stated, is the idea of taking a portion of software and looking at it in the same ways that an adversary might and understanding all the possible ways that an attacker might try to take advantage of the software to gain its assets or to take advantage of the computer that is running that software itself. Again, this is another section that will be talked about in much greater depth in one of the subsequent talks. During the implementation stage of the project, there are a number of things that we ask product development teams to look at to help make sure that they're building software that is maximally secure. Some of these are as simple and trivial as the build tools and build options that the teams select in terms of how they compile their software. Visual Studio 2005 has some great improvements in this area, including some improved stack protections via the /GS switch, safe exception handling, and the no execute option, all of which, when appropriately deployed, can help teams build binaries that have greater levels of defense in depth, that even if they were to release with a vulnerability that was not caught by some of the other options, these additional layers of defense in depth would help them deliver more secure solutions. We also have a number of static analysis tools that we use. FXCOP for managed code has been out for quite some time, and the Analyze option in Visual Studio 2005, that's also been previously known as Prefast, is another static analysis option for unmanaged code that will help teams identify a number of common coding implementation vulnerabilities in their code that will, again, help them ultimately release higher quality code. We also, during the implementation phase, ask teams to carefully consider looking at the deployment guidelines and other forms of documentation and tools that they make available to our customers to help our customers make sure that they can deploy our software in a secure state on this. While it is very common for engineers to focus on the product code per se and making sure that it is of high quality, if the code is not deployed and configured securely, even the best written code can be taken advantage of by an adversary because it wasn't deployed by the customer optimally. So this is another important consideration to keep in mind during the implementation phase of the project. Moving on to the testing phase, or the verification stage as it's typically referred to inside of Microsoft, there's a number of other different testing activities that we encourage teams to follow. Fuzzing, as you've read in the book, is a very common practice of taking any code that parses untrusted data input and feeding it unexpected or maliciously crafted data to make sure that the parsing code is robust and that the parsing code does not contain defects that, if they were encountered, would ultimately result in the code being vulnerable. Fuzzing is a very important strategy that we use at Microsoft to make sure that all of our data parsing code is of high quality and robust. There are a number of other fuzzing can be applied widely at the file level, at the network interface level, or at any other level where there's a portion of code that consumes data from untrusted sources. There's also several other great testing tools that are out there. The App Verifier tool that is available for download from Microsoft.com is another tool that runs in the background and looks for heap corruption and other types of defects in implementation defects in code in such a way that if you run that in the background while running a full set of test suites, again, it can help uncover defects in code that correcting those can result in higher security quality of the code. Also during the verification stage, a lesson that Microsoft has sadly learned the hard way is the importance of preparing a security response plan. The basic idea here is to consider what will happen to your code and to your customers after that code is released, and if a security vulnerability is found in it, and how you as the software vendor will respond to that to make sure that you take quick, actionable steps to protect your customers. Thinking through these things before the software is released is a much better way of going about the process than to wait till afterwards when, in the middle of a security incident, you're having to scramble to figure out how you'll go ahead and deal with that and how you'll deploy patches to customers. An ounce of foresight is worth a pound of cure in this particular case. Also in the verification stage is something that you may have read about in the earlier days of Microsoft, the notion of a security push. The security push, simply stated, is the point in time where you've got time and resources carved into your development schedule to go back and make sure that nothing that has changed as the product has been developed after the implementation phase has altered the security stance of the project. Making sure that your threat models are up to date, going back and having the opportunity to revisit any legacy code that might not have been modified in this version, and taking advantage of all the greatest tools and testing techniques that you can to, again, ensure that things that may have changed during the development process come out being maximally secure. We also engage in penetration testing team activities. This is a fairly well-known activity in the industry, hiring people that are expert at hacking into and breaking into systems and going through this type of process prior to the product being released to make sure that the ultimate released product has addressed all of these types of issues that security professionals may have discovered by trying to examine and poke and prod it in interesting ways. As we now move to the release stage of the project, there's an activity referred to as the final security review. The final security review, simply stated, is the process of a person with security expertise and understanding of the SDL process, who is also outside of the organizational structure of the product development team, looking at the software and trying to answer the simple question, is this software ready to be released to customers from a security point of view? This is not intended to replace all of the other activities that go earlier in the security development lifecycle, but rather to look at and verify that they've been followed accurately and correctly. Finally, once the software has gone through all of the processes that encompass the security development lifecycle and it has successfully passed its final security review, the product is then released and goes into the hands of our customers. It's very important because in the changing security landscape and with different types of attacks that are becoming known and different techniques that are used by security researchers to analyze products, it may well be the case that with some future technique or with some future approach that even software that was believed to be maximally secure upon release, security defects may be found later on. It's vitally important to make sure that there's a well-defined and a well-understood support vehicle that customers can turn to and depend on to make sure that they get updates to their software in a timely and a timely fashion that will enable them to remain maximally secure. And again, this is a very important part of the overall security development lifecycle. While it doesn't directly impact the processes that go into building software up until the point it's released, it's critically important to think through what that servicing model will be after the software has been released and is in the hands of customers. So with that brief high-level summary of the security development lifecycle, While there are many different ideas and thoughts that are circulated in the marketplace and in the industry on how to build more secure software, the ultimate test of success of any of these processes is how successful is it in reducing the number of vulnerabilities in product. With some of the graphics that you see here that talk about several different Microsoft products, comparing versions of operating system releases, our Office product line, our Exchange Server product line, you'll see that in each one of these cases, the number of bulletins in these examples that are also commensurate with vulnerabilities actually is reduced in those releases that have followed the security development lifecycle. The general rule of thumb we have is that for any product going through the security development lifecycle that had not previously, we see an approximately order of magnitude improvement, in other words, cutting in half of the number of vulnerabilities from the preceding version. Similarly, with a handful of other products here, our IIS Server, SQL Server, and Internet Explorer, in all of these cases, the key message to take away from this is we believe the security development lifecycle is an approach that can work regardless of the particular product or particular technology being used. The core concept here is by applying a holistic process that goes throughout the software development lifecycle, where appropriate activities relative to the stage of software development to improve security quality can get factored in, ultimately will result in a higher quality product and less vulnerabilities in that product. While obviously at Microsoft we are big believers in the security development lifecycle and have embraced this throughout our entire product line and our services line, some of the other testimonials for this come from a recent quote from the RSA conference by John Pescatore, a vice president at the Gartner Group. The statement speaks for itself in terms of even that some of the industry analysts that look around at what all vendors in the industry are doing, including Microsoft, really believe that the security development lifecycle is the industry-leading best practices for building more secure software in a very general sense. The lessons that we've learned over the years, going back to the infamous Bill Gates Trustworthy Computing Memo from 2002 all the way up to date, is that as we started off by just simply trying to go out and looking for security defects in various products and code, ultimately is not the most successful strategy to getting more secure code. It needs a holistic process similar to many other studies that have been done in computer science, showing that the most successful strategies are those that can prevent defects from ever entering the code at the earliest possible stage. The later in the development cycle you wait to address defects and issues, the more costly and time intensive it is to try and address those things in an effective way. The core message of the security development lifecycle is to look at each stage of the development process and ensure that the appropriate activities are followed in each stage of the development process that can result in more secure code. Doing this is certainly not a trivial process nor a cheap one. It requires executive commitment to make sure that time, energy, and resources can be applied to solving this problem. It requires education. While many people coming out of university systems across the world may have a great background in understanding cryptography or access control, most of them typically don't have an understanding that writing a file parser, if not written correctly and there are parsing defects in that, can ultimately result in vulnerabilities that could allow users of that code to become compromised. We've made a big commitment here at Microsoft to an education and training program for all staff that are involved in product development responsibilities, and ultimately, people can't do things that they don't have the necessary skills and background and training to accomplish. Education is a critically important portion of the security development lifecycle. Finally, security is not a static entity. There are a number of new attack techniques and approaches that are being used and come out every year. In order to stay current and responding to threats and activities going on in the security landscape today, the security development lifecycle is a flexible process where we'll continue to add new things, new technologies, new processes once the need for those arises and new technologies and new processes are developed that can be applied to those problems and demonstrate successful results. In summary, the security development lifecycle is a holistic process that Microsoft has found to be very successful in reducing the number of vulnerabilities across our product line. While neither cheap nor easy to implement, as some of the information in this book will hopefully be of use to you, We do believe that this is the best practice, the industry-leading practice in reducing vulnerabilities in commercial software products that exist today. Thank you.